Okay, just want to check a homework. Okay, so for question 16, we're told a particle is projected up a plane which is inclined at 30 degrees to the horizontal, and the particle is projected from a point on the plane and it's got initial velocity of 10 meters per second at 45 degrees to the inclined plane. So the initial speed is 10 meters per second, and the plane is inclined at an angle of 30 degrees to the horizontal. That 30 degrees is what we call beta. So the angle beta is 30 degrees. That's the angle the inclined plane makes relative to the horizontal. The angle alpha is the angle the projectile makes relative to the inclined plane. And the angle alpha is 45 degrees. So the first thing we always need to calculate anyway is the initial velocity vector u. So u is always u cos alpha I plus u sine alpha j. U stands for the speed, and alpha is the angle the particle makes relative to the inclined plane. So here, the initial velocity vector u is going to be 10 cos 45 degrees I plus 10 sine 45 degrees j. If you put 10 cos 45 into your calculator, it works out as 5 root 2. Similarly, if you put 10 sine 45 degrees into your calculator, it also works out as 5 root 2. So we have the initial velocity vector u. Okay, so u is 5 root 2I plus 5 root 2j. So you cannot answer anything without knowing the initial velocity vector. So ux is 5 root 2, and uy is also 5 root 2. So the first thing we have to calculate is the maximum perpendicular height above the plane. So when you're looking for the maximum height, you're looking to find sy when, what's the condition? Vy equals 0. So we're looking to find sy, and this occurs when Vy equals 0. Every time you solve your condition, what does it always give you? Time. Now the equation for Vy is uy minus g cos beta times t. So remember, uy is u sine alpha, and that's followed by g cos beta. So Vy is going to equal uy minus g cos beta times t. Now we're just after working out uy as 5 root 2. The angle beta is 30 degrees. So this means 0 is going to equal uy is 5 root 2 minus g times cos of 30 degrees times t. Cos of 30 is root 3 over 2. So this means 0 is going to equal 5 root 2 minus g times root 3 over 2 times t. And that's the same as root 3g over 2 times t. To get rid of fractions, we'll multiply everything by 2. And 0 equals 10 root 2 minus root 3g times t. And this means then if you bring this over, you're going to get root 3gt equals 10 root 2. And then to get t in its own, if we divide the 10 root 2 by root 3gt, by root 3g, sorry. So that means t on its own is going to be 10 root 2 over root 3 times g. So this represents the time taken for the particle to reach the maximum perpendicular height above the plane. We now have to substitute this time into the equation for sy. Now sy is uyt minus a half g cos of beta times t squared. What's uy in general? Uy is, but in general, It's just u sine alpha. What follows u sine alpha? G cos beta. Okay, so that's how you know these equations. If you've got a u sine alpha, it's followed by a g cos beta. So sy is uyt minus a half g cos beta times t squared. So we're looking to find out what sy is. What's uy? 5 root 2. The time is 10 root 2 over root 3g minus a half g times the cos of beta, but the angle beta is 30 degrees, times the time, which is 10 root 2 over root 3g, all to be squared. So we replace the ui with 5 root 2. We replace the time t with 10 root 2 over root 3g. And then we've got minus a half g, can be written as g over 2, cos of 30 by 10 root 2 over root 3g, all to be squared. Now, what's the cos of 30 again? Root 3 over 2. So the cos of 30 is root 3 over 2. When you square this fraction, you square the top. Squaring 10 gives 100. Squaring root 2 gives 2. 2 by 100 is 200 on top. Root 3g to be squared. Squaring root 3 gives 3. Squaring g gives g squared. Okay, next of all, what's going to happen to the g on top and the g squared on the bottom? The g cancels with the square. 2 by 2 is 4. The 4 divides into 200 to give what? 50. Okay, so the g cancels with the square, and the two 2's multiplied together give 4, and 4 into 200 gives 50. So sy then, we've got 100 over root 3g minus 50 root 3 all over 3g. Now, because we've got 3g in the bottom at this term, we'd like a 3g in the bottom here. So we need to multiply top and bottom by root 3, because root 3 by root 3 gives 3. So we're just multiplying top and bottom by root 3. So this gives 100 root 3 all over 3g. And then 100 root 3 over 3g minus 50 root 3 over 3g just gives 50 root 3 over 3g meters. So this is the maximum perpendicular height of the particle above the plane. So it's just these surds that makes that awkward, okay? Anytime you're dealing with 30, 45, or 60 degrees, you're always going to be dealing with surds. Okay, so that was part 1. In part 2 now, we want to find the range of the particle. When you're looking to find the range, you're looking to find Sx, but what's the condition? Sy equals 0. When the particle lands, the height above ground is 0, so Sy is 0. So for the range, we need to find Sx, and this occurs when Sy equals 0. Now the equation for Sy again, Sy is uyt minus a half g cos beta times t squared. Remember, what's uy in general? And that's followed by g cos beta. So uy is u sine alpha in general, and that's followed by g cos beta. So here then, when the particle lands, Sy is 0. What was uy? 5 root 2 times t minus a half g is g over 2 times the cos of 30 degrees times t squared. Once again, what is the cos of 30? Root 3 over 2. What is g over 2 by root 3 over 2? Why don't you multiply the tops and the bottoms? So what's g over 2 by root 3 over 2? Can you write that answer? 2 by 2 is root 3 by g? Root 3g. So this means 0 equals 5 root 2t minus root 3g over 4 by t squared. So the cos of 30 is root 3 over 2. Next of all, the bit of fractions. What do we multiply everything by? 4. And this becomes 20 root 2t. So 0 equals 20 root 2t minus root 3 gt squared. This is a quadratic equation which has got no constant term. How do you factorize a quadratic which has got no constant term? And what do we take out? T. So if we take out a t, we're left with 20 root 2 minus root 3 gt. Okay, and next of all then, if we solve this, so 20 root 2 is going to equal root 3 gt. So 20 root 2 divided by what equals t? Root 3g. So the time is going to be 20 root 2 over root 3g. That's the time of flight. We're now going to substitute that time into the equation for Sx. Now, what is the equation for Sx? Sx is just uxt minus a half g sine beta times t squared. What's ux in general? What follows u cos alpha? G sine beta. Okay, so that's just how you memorize these. Okay, so here then, Sx is going to equal, now what's ux? 5 root 2, and the time is 20 root 2 over root 3g minus half g is g over 2 times the sine of beta, which is a sine of 30 degrees times t squared. What's the sine of 30? Half. And if you square a fraction, you square the top, square the bottom. If you square the top, that's 400 by 2. That's going to give you 800 on top. If you square the bottom, you get 3g squared. 5 root 2 by 20 root 2. 5 by 20 is 100. Root 2 by root 2 is 2. So that's going to give 200 all over root 3g. So Sx works out as 200 over root 3g minus g over 2. The sine of 30 is a half. And squaring this fraction gives 800 over 3g squared. Now, 2 by 2 gives 4, and 4 divides into 800 to give 200. And what happens to g in the square? They cancel out. So the g and the square cancel out. 2 by 2 gives 4, and 4 into 800 gives 200. Now you'll notice we're left with a 3g on the bottom here. What do you need to multiply this by to make it 3g? Root 3. If you multiply the bottom by root 3, you have to multiply the top by root 3. So we've got 200 over root 3g by root 3 over root 3 minus 200 over 3g. And this gives 200 root 3 all over 3g minus 200 all over 3g. Now, what can we factorize out of these two terms? What do they have in common? On the bottom, anything else? 200. So if we take out the 200 over 3g, we're still left with root 3 minus what? If you take out the 200 and the root 3, what are you still left with? So if I take out this 200 and this 3g, what are you still left with? Here you're left with root 3. What happens if you factorize it out of here? 1. You're still left with 1. Because when you multiply that back in, that gives 200 root 3, and 200 by the minus 1 gives the minus 200. So Sx is 200 on root 3 minus 1 all over 3g.
Are these common?
Are these common?
These are
Like this would be a part B type question, yeah. Like on the exam, you'd always get part A is always projectiles on horizontal planes, part B is projectiles on inclined planes. What makes these awkward is the surds. Okay. Now, later on today, we're going to look at questions where you're not given the actual angle as 30 degrees, 45 degrees, or 60 degrees. So you could be told that the angle beta is inverse tan of 3/4 or something like that. In that case, you're not dealing with surds, it's just fractions. Okay, and that probably would be a little bit more common. And it's just the answer is a little bit more neater to deal with then. Okay, next of all, we want to find the speed. To find the speed, we need to know the velocity vector when the particle lands. We need to know Vx and Vy. So the velocity vector V is Vxi plus Vyj. And using my tangent theorem, it then gives the speed. Now we need to find the velocity vector when the particle lands. But we already solved when Sy was 0, that time was 20 root 2 over root 3g. So to find Vx, now the equation for Vx is ux minus g sine beta times t. Remember, what's ux in general? U cos alpha, that's followed by minus g sine beta times t. So here Vx is going to equal, now what was ux? 5 root 2 minus g times the sine of 30 times the time t is 20 root 2 over root 3g. Now, what is the sine of 30? A half. So half g can be written as g over 2. And then what happens? The g's cancel, and 2 divides into 20 to give it 10 root 2. So this means Vx is going to be 5 root 2 minus 10 root 2 all over root 3. So we still have the root 3 in the bottom. Now, if we want a root 3 in the bottom here, we're going to multiply top and bottom by root 3. So this means Vx is 5 root 6 over root 3 minus 10 root 2 over root 3. Now, this is working out so awkward. It's not working out as a nice surd even. So we can just give the decimal equivalent. Okay. So as a decimal number, that works out as minus 1.09. If you put in 5 root 2 minus 10 root 2 over root 3 in your calculator, it'll straight away give you the minus 1.09. Okay. So multiplying top and bottom by the root 3. In this case, didn't simplify it anyway. Okay, so that's Vx. The next thing we have to work out is Vy. Vy must always work out as minus Uy. Okay, you cannot assume that, you must always prove it. Okay, so what was Uy? What must Vy work out as? Minus 5 root 2. Okay, and you cannot assume that. That's something you need to always prove. So the equation for Vy is Uy minus g cos of beta times t. Once again, what's Uy in general? So that's followed by g cos beta. Okay. So you do need to know these formulae. Okay, they're not given in the tables. These formulas are expected to be able to write down yourselves. So this means then Vy is going to equal Uy is 5 root 2 minus g times the cos of beta is the cos of 30 degrees and the time t is 20 root 2 all over root 3g. So what is the cos of 30? Root 3 over 2. So root 3 over 2 by the g is root 3g over 2. Now, what happens to root 3g on top and the root 3g in the bottom? They cancel out. Now, what's 20 root 2 divided by 2? 10 root 2s. So we've got 5 root 2 minus 10 root 2's. And what is that just? Minus 5 root 2. Okay, that must happen every single time. Vy must work out as a minus uy. Okay, so next of all, if we want to calculate the speed, the magnitude of your velocity vector is the square root of vx squared plus vy squared. So you're just using Pythagoras' theorem. So the magnitude of v is the square root of vx squared plus vy squared. So the vx was the minus 1.09 squared plus, and the vy was minus 5 root 2 squared. So using Pythagoras' theorem, the speed works out as 7.15 meters per second. Okay, question 17. A particle is projected up a plane which is inclined at 45 degrees to the horizontal. The particle is projected from a point on the plane and has got initial velocity 20 meters per second at 30 degrees to the inclined plane. So again, this diagram represents what's happening. So this is your inclined plane, and the inclined plane makes an angle of 45 degrees with the horizontal. This is what we call our angle beta. The particle itself makes an angle of 30 degrees with the inclined plane. So this is your initial velocity vector u. The speed is 30 and it makes some angle 30. So here, first thing we always need to calculate is the initial velocity vector u. And u is u cos alpha I plus u sine alpha j. What's u? What's the speed? 20. What's the angle alpha? 30 degrees. So u is going to be 20 cos 30 degrees I plus 20 sine 30 degrees j. Now, cos of 30 is root 3 over 2. When you multiply that by 20, that's 10 root 3. The sine of 30 is a half. 20 by a half gives 10. But your calculator will work these out straight away for you. So 20 cos 30 is 10 root 3. 20 sine 30 is just 10. So your initial velocity vector u is 10 root 3i plus 10j. Ux is 10 root 3 and uy is 10. Okay, so again, the first thing we're going to calculate is the perpendicular height. So to find the maximum height above the plane, we're looking to find sy, and this occurs when? What's the condition? Vy equals 0. So we need to find sy, and this occurs when Vy equals 0. Now, the equation for Vy equals Uy minus g cos of beta times t. So remember, Uy is u sine alpha, and that's followed by g cos beta. So what did we work out Uy as? 10. And what's the angle beta? 45 degrees. So 0 equals 10 minus g times the cos of 45 by t. Now, cos of 45 is root 2 over 2. So this means 0 equals 10 minus root 2g over 2 times t. Again, to get rid of fractions, we just multiply across by 2, and 0 equals 20 minus root 2 gt. And this means then 20 equals root 2 gt, and your time t then is going to be 20 over root 2g. So 20 divided by the root 2g equals the time t. So this represents the time taken for the particle to reach the maximum perpendicular height above the plane. We now need to substitute this time into the equation for sy. Again, sy is uyt minus a half g cos of beta times t squared. Okay, so you do need to know these off by heart. So again, uy is u sine alpha, so that's going to be followed by a g cos beta. Once again, what was uy? 10. The time is the 20 over root 2g minus a half g is g over 2 times the cos of beta, which is the cos of 45 degrees, times your time, which is 20 all over root 2g all to be squared. Now, this is going to give 200 over root 2g minus g over 2. Cos of 45 is what? Root 2 over 2. And when you square this fraction, what happens when you square the top? 400, isn't it? That's going to give you 400. And what happens when you square the bottom? 2g squared. Okay, so here we've got 200 over root 2g. And what happens to g and the square? They cancel. 2 by 2 is 4, and 4 goes into 400 to give 100. So here we're left with 100 root 2 over 2g. And here we've got 200 over root 2g. Now, to change this to a 2g, what do you need to multiply this by? I want to change that to a 2g, root 2. If you multiply the bottom by root 2, you have to multiply the top by root 2. So we're just going to multiply top and bottom by root 2. And this gives 200 root 2 over 2g minus 100 root 2 over 2g. And that works out as 100 root 2 over 2g. But the 2 goes into the 100 to give 50. Okay, well, I've left it like that. You could have written that as 50 root 2 all over g. Okay, so that can be written as 50 root 2 over g meters as well. So that's the maximum perpendicular height above the plane. Okay, next of all, if we want to calculate the range. So again, with the range, we're looking to find Sx, and the condition is when Sy equals 0. So for that range, we need to find Sx, and this occurs when Sy equals 0. Once again, the equation for Sy is uyt minus a half g cos of beta times t squared. Again, just automatically thinking uy is u sine alpha. That's followed by g cos beta. What did uy work out as? 10. So 0 is going to equal 10t minus a half g is g over 2 times the cos of beta is the cos of 45 times t squared. Once again, what is the cos of 45? Root 2 over 2. And when you multiply that by g over 2, that's going to give root 2g over 4. Now, if we want to get rid of fractions everywhere, what do I multiply everything by? 4. And 0 is going to equal 40t minus root 2g t squared. Again, this is a quadratic equation with no constant term. What can we factorize out? T. And if we take out the t, we're left with 40 minus root 2 gt. The trivial solution is t equals 0. So when time was 0, the particle was on ground level. But we're looking for the next time it hits the inclined plane. So that means the time is going to be 40 over what? 40 over root 2g. So the time of flight is 40 over root 2g. We now need to substitute that time into the equation for Sx. So Sx is uxt minus a half g sine of beta times t squared. What did ux work out as? 10 root 3. The time is 40 over root 2g minus a half g can be written as g over 2 times the sine of beta is the sine of 45 and the time is 40 over root 2g. Now when we multiply 10 root 3 by 40, that's 400 root 3 over root 2g minus g over 2. Sine of 45 is root 2 over 2. And what happens when we square this? What do you get on top? Over 1600 over 2g squared. So this gives 400 root 3 over root 2g minus g over 2. Sine of 45 is root 2 over 2. And this is 1600 over 2g squared. Now again, 2 and the 2 is 4. And that divides into 1600 to give 400. And the g cancels with the square. Now here we've got a 2g on the bottom. What do we need to multiply this by to make it a 2g? Root 2. To multiply the bottom by root 2, you have to multiply the top. So we're going to multiply top and bottom by root 2. So this gives 400 root 6 over 2g minus 400 root 2 over 2g. Now we could factorize out the 400 over 2g, and we're left at root 6 minus root 2. So Sx is 200 on root 6 minus root 2 all over g. Okay. So the 2 divided into the 400 to give 200. That's where the 200 came from. Okay, so we've calculated the maximum height and the range. Next of all, we're going to calculate the speed of the particle when it lands. Once again, when the particle lands, the time is 40 over root 2g seconds. So when the particle lands, time is 40 over root 2g. So we need to find Vx and Vy. Now the equation for Vx is ux minus g sine beta times t. What was ux? Initial velocity in the x was 10 root 3 minus g times the sine of beta. What's the angle beta? 45, and t is 40 over root 2g. Once again, what is the sine of 45? Root 2 over 2. Okay, so we've got a root 2g over 2. Now what happens to root 2g on top and the root 2g in the bottom? They cancel. And 40 divided by 2 is 20. So Vx is 10 root 3 minus 20. Okay, and again, just as a decimal, that works out as minus 2.68. So we found Vx. What was Uy? Uy was 10. What must Vy work out as? Minus 10. Okay, again, you have to always prove that. So the equation for Vy is Uy minus g cos of beta times t. So this means Vy is going to be Uy is 10 minus g times the cos of 45 by the time t is 40 over root 2g. What is the cos of 45? Root 2 over 2. Both cos and sine of 45 give the same thing, root 2 over 2. Now we've got a root 2g on top, root 2g in the bottom. What's going to happen then? Cancel. What's 40 divided by 2? 20. So Vy is 10 minus 20. So what's Vy? Is that correct? Okay, so Vy worked out as a minus Uy. So using Pythagoras' theorem, then we can work out the speed of the particle when it lands. So the magnitude of V is going to be the square root of minus 2.68 squared plus minus 10 squared. So if we use Pythagoras' theorem with these two numbers, the speed is going to be the square root of minus 2.68 squared plus minus 10 squared. And what does that work out as to 2 decimal places? Can we get an answer? 10.35. So the speed is 10.35 meters per second. Okay, so what made them so awkward was we were using these special angles. We were using 30, 45, and 60. However, more than likely, you probably won't be given the angles like that. Okay, now you can be given them, but what they generally do in exams is to give you the angles in terms of tan. Okay, it's actually easier this way. Okay, so if you look at example 5 in the workbook, so this is on page 26 of the workbook. Okay, so rather than finding the speed of the particle when it lands, we're going to find the angle. What rule do we always use to find the angle? The tan of the angle is the what over the what? Positive j over the positive I. Okay, but that's got from the velocity vector when the particle lands. Okay, so here we're told that a plane is inclined at an angle alpha, which is inverse tan of 3/4 to the horizontal. That means the tan of alpha is 3/4. A particle is then projected up the plane with initial speed of 13 meters per second at an angle beta, which equals inverse tan of 5/12 to the inclined plane. Okay, in that question, sorry guys, the alphas and betas are the wrong way around. Okay, just have to notice on that there. See the way it says a plane is inclined at an angle alpha, which equals inverse tan of 3/4 to the horizontal. That should be beta. Is that okay? So change that alpha to a beta. Oh, does it not in your one? Yours, okay, so you actually have it the right way around. It's my one that's the wrong way around. Okay, so you have a beta here, do you?
No, we don't have any.
A plane is inclined at an angle. Okay, it's inverse tan of 3/4 to the horizontal. Okay, that is the angle beta. Okay, so beta is inverse tan of 3/4. Okay, so this one should be beta and this one should be alpha. So the particle is projected up the plane with initial speed 13 at an angle. This should be alpha is inverse tan of 5/12. Okay, so this should be beta and this should be alpha. Let's change that here. Okay, so that's your angle beta, that's your angle alpha. Okay, and then this is just what they use in the exam. The plane of projection is vertical and contains the line of greatest slope. That just means that you're dealing with 2 dimensions. Is that okay? So this is the way it come up in an exam, because you can do projectiles in 3 dimensions, but for leaving cert, you only deal with 2-dimensional coordinate geometry. Is that okay? So it is only 2 dimensions. Okay, so the particle just goes in a straight line. It's not going over at an angle. Okay. So if you see that the plane of projection is vertical and contains the line of greatest slope, that's just there because you're just dealing with 2 dimensions. Is that okay? And then it says, show that the angle at which the particle strikes the plane works out as inverse tan of 10/9. Okay, so to get this angle, we need to find the velocity vector when the particle lands. Okay, and if we get the angle this vector makes, that's called the landing angle. Okay. So the first thing we need to work out anyway is the initial velocity vector u. So remember, u is u cos alpha I plus u sine alpha j. Now you can see from this, the tan of alpha equals what over what? tan of alpha is what fraction? 5 over 12. The tan of alpha is 5 over 12. What's the tan of beta? 3 over 4. Okay. So when you bring this inverse tan over, it becomes tan on the other side. Tan of alpha is 5 over 12. Tan of beta is 3/4. Okay. Now, if the tan of alpha is 5 over 12, tan uses the ratios of two sides in a right angle triangle. What two sides does tan use? Opposite over adjacent. So if you draw a right angle triangle and mark in some angle alpha, so in this black right angle triangle, we've got this angle alpha. What's the length of this side across from it? 5. And the adjacent is 12. Not 5, that's 12. Now, what happens if you square 5? Square 12? 144. What's 25 and 144? And the square root of 169 is 13. So this other side is then 13. Okay. Now that we have the three sides in the right angle triangle, what two sides does sine use? Opposite over hypotenuse. So what would the sine of alpha be? 5 over 13. What about the cos of alpha? So cos will be 5 over 13. Okay. So now that we know what sine alpha and cos alpha are, we can work out the initial velocity vector u. So remember, u is always u cos alpha I plus u sine alpha j. U stands for the speed. Now we were told, what was the speed? 13. So it's going to be 13 times 12 over 13i plus 13 times 5 over 13 times j. And the 13s cancel. So u just works out as 12i plus 5j. Okay, so that is the initial velocity vector u. Remember, you cannot answer anything without knowing that initial velocity vector. And we'll also need to know what the sine and cos of beta are as well. What's the tan of beta? 3 over 4. So tan uses the opposite and the adjacent. So if we draw another right angle triangle and mark in some angle beta, the tan is the opposite over the adjacent. We've got a 3 as the opposite, 4 as the adjacent. What's 3 squared? 4 squared? Add them together. What's the hypotenuse going to be? 5. Okay, so we've got 3, 4, 5. That is the simplest case of Pythagoras' theorem. So what would the sine of beta be? 3 over 5. Sine uses the opposite and the hypotenuse. The sine of beta would be 3/5. And what about the cos of beta? 4 over 5. Okay. So when the angles are given in terms of inverse tan, you don't have square roots. Okay, so it's just set up this way so that you don't have square roots. Okay, now if we want to find the landing angle, we need to use the velocity vector when the particle lands. Okay, so the tan of L is going to be minus Vy over Vx, and this occurs when Sy equals 0. Now, what did I say about Vy? What does it always work out as? Minus Uy, okay? And that minus by minus will change that to a plus. So remember, the tan of L is the positive j over the positive I. Okay, so Vy works out as a negative, and that minus is going to change it to a plus, and Vx then will be a positive. So this occurs when Sy equals 0. Okay, what happens when Sy equals 0? Whereabouts is the particle? Landing. Okay, so that's when the particle lands. Sy equals 0. So every time you solve a condition Sy equals 0, what does it always give you? Time. So this will give us the time of flight. So Sy is Uyt minus a half g cos of beta times t squared. And what was Uy? 5. So 0 is going to equal 5t minus a half g is g over 2. And what did the cos of beta work out as a fraction? 4/5 times t squared. And here 0 equals 5t minus the 2 divides into that, and that will give you that's going to give you 2g squared, 2gt squared all over 5. Okay. And then if you multiply across by 5, so the 2 goes into the 4 to give 2. And the 5, if you multiply across by 5, 0 equals 5 or 25t minus 2gt squared. Okay. So multiplying across by 5 gets rid of the fraction. 2 divides into the 4 to give it 2. So here we're going to be left at minus 2gt squared, and then multiplying across by the 5 changes this to 25. So 0 then equals 25t minus 2gt squared. This is a quadratic with no constant term. What can we do? Take out a t. And if you take out the t, you're left with 25 minus 2gt. And then this means t is 25 over 2g. So this represents the time of flight. We now need to substitute this time into the equation for Vx and Vy. Okay, so I've done Vy. First of all, this is sort of a checking mechanism. What should Vy always work out the same as? Minus Uy. So if this works out correct, you'll know you're on the right track. Vy is Uy minus g cos of beta times t. Vy is going to equal, what was Uy? 5 minus g times, what was the cos of beta as a fraction? 4 over 5. And what's the time t? 25 over 2g. Now here, the 5s will cancel. The 5 divides into 25 to give a 5 on top. The g's cancel. And then the 4 can be divided by the 2 to give 2. So that's going to give 2 by 5, which is 10. So Vy is going to equal 5 minus 10, and that does equal minus 5. Okay, so the g's cancel. 2 divides into the 4 to give it 2. 5 goes into 25 to give a 5. And the 2 by the 5 will give it 10. So Vy works out as minus 5. Is that correct? Yeah. Okay, because Uy was 5. Vy has to be a minus 5. Okay, next of all, we're going to work out what Vx is. Now, the equation for Vx, it's Ux minus g sine of beta times t. So Vx is Ux minus g sine beta times t. So Vx is going to equal, what was Ux? 12 minus g times, what's the sine of beta as a fraction? 3/5. And the time t is 25 over 2g. Now what happens here, the g's cancel. 5 goes into 25 5 times, and that's 3 5s is 15 over 2. So Vx is 12 minus 15 over 2, and that works out as 9 over 2. So 12 over 1 can be written as 24 over 2. 24 over 2 minus 15 over 2, that works out as a plus 9 over 2. So remember, the angle a vector makes is the positive j over the positive I. Okay. So the positive I is 9 over 2. And what's the positive j? So what Vy worked out as a minus 5, isn't it? So this means that if the tan of L is minus Vy over Vx, minus Vy changes that to a plus 10, and Vx is 9 over 2. Oh, sorry, a plus 5. Okay. Vy was minus 5, minus Vy changes that to a plus 5. And that's all over 9 over 2. And a fraction divided by a fraction, you turn the bottom upside down and multiply, and that gives 10 over 9. So this means L is what we're calling the landing angle. L is going to be inverse tan of 10 over 9. Okay. So rather than finding the speed, here we found the landing angle. And the reason why this worked out as a fraction was because the cos of alpha, cos of beta, sine alpha, and sine beta, they were all fractions. Okay. Okay, so just one last thing I want to show you. I'm going to let you try some questions. We've been looking at projectiles up an inclined plane. With projectiles down an inclined plane, this is what the diagram looks like. So you can see if a particle is projected from this point, this time the y-axis or the x-axis is going down. Okay, your j-axis is always perpendicular to your y-axis. What does perpendicular mean? 90-degree angle. Okay, so what happens in this case is the particle sort of lands below your starting point. Okay, now gravity again always acts straight down, but when we split the gravity up into j components and I components, okay, so if that's an angle beta here, this is the angle the inclined plane makes with the horizontal. If that's an angle beta, this is an angle beta up here also. This is g cos beta and this is g sine beta. Now, the only difference between projectiles down an inclined plane and projectiles up an inclined plane is gravity. And what do you notice about this j-axis? What direction is it moving? What does that mean about gravity? If the gravity acts up in the j-axis, is it positive or negative? So what happens if you throw an object up? That means what? It's a minus g. Okay. So along the j, it's going to be a minus. Okay, because that's going up. But if you're dealing with down inclined plane, what do you notice about gravity along the I this time? It's going to accelerate. Okay, this is moving down the plane. So the only difference between projectiles up an inclined plane and down an inclined plane is gravity on the I component or the x component is a positive instead of a negative. Okay, so the two equations change very slightly. So remember we had v equals u plus at. Vx is going to be ux plus ax times t. But here ax is a plus g sine beta. So why is this a plus again? Because the gravity's acting downwards. Okay, so that's the only difference. Before we had a minus here. So Vx then just equals ux plus g sine beta times t. That's the only difference. The Vx has a plus instead of a minus in it. Okay. If you want to formulate the equation for Vy, Vy is uy plus ay times t. But ay is going to be a minus g cos beta. And why is that a minus g still? Because in the y, what direction are you going to? It's going against gravity. It's going up. So this has a minus in it. So that's the same as before. So Vy is u sine alpha minus g cos beta times t. No change with this one. So Vy is exactly the same. The only difference is for Vx, it's got a plus instead of a minus. Now, in your notes on page 25, you have projectiles up an inclined plane and you've got projectiles down an inclined plane. Okay, so you have all of these formula. So these are given on page 25. Okay, and similarly then, if we want to work out both Sx and Sy, what's the only difference going to be for Sx? You're going to have a positive with the gravity. Okay, and Sy will be the very same. So S equals ut plus a half at squared. This means Sx is going to be uxt plus a half ax times t squared. But ax is going to be a plus g sine beta. So this means Sx is uxt plus a half g sine beta times t squared. So again, the only difference is instead of a minus, we've got a plus. Okay? And that is the only difference. Is that okay? So when you're dealing with projectiles up or down an inclined plane, the only difference is Vx and Sx have a plus instead of a minus in the middle. Okay, that is the only difference. Everything else is identical the same. Okay, and the equation for SY is the same as before. So SY is UYT plus a half AYT squared. So SY is going to be UYT plus a half minus G cos beta times T squared. So again, SY is U sine alpha T minus a half G cos beta times T squared. So on page 25 of your workbook, you have all of these formulae. Okay, so on the left, we projectiles up an inclined plane. On the right, we projectiles down an inclined plane. So the only difference is with Vx and Sx have a plus in the middle instead of a minus. Okay, everything else is done exactly the same. Okay, so I'm going to get you to do questions 18, 19, 20, 21. Okay, let's start them there.